Hello everyone, my name is Janish Desai. Today I am going to explain two of the most widely used analog modulation techniques, amplitude modulation and frequency modulation. So first of all, these techniques form a foundation of radio communication. So now we have question what is modulation and why it is necessary. So modulation is necessary because the original message signals such as voice or music are at low frequency signals. Low frequency signals cannot travel long distance on their own. So we combine them with a high frequency carrier wave. So AM and FM have been used for decades for broadcasting, aircraft communications, navigation systems, and two-way radios. Even though we use digital communication today, understanding AM and FM helps us understand how radio communication originally evolved and how analog systems still operate many industries. Then we have AM. So what is AM? In the amplitude modulation, the amplitude of the carrier wave changes according to the amplitude of the input message signal. The frequency and phase of the carrier remain unchanged. Amplitude modulation is very easy to generate and detect. Receivers can be made using simple and inexpensive circuits like envelope detectors, which is why AM radios were very popular for many years. Amplitude modulation requires smaller bandwidth, usually about twice the maximum frequency of the modulating signal. For example, for a 5 kHz audio signal, we need only about 10 kHz of amplitude bandwidth. However, the major drawback of amplitude modulation is that it is highly sensitive to noise and interference. Any electrical disturbance like lightning, motors, or atmospheric noise affect the amplitude directly, causing crackling or static in the audio. Even with these disadvantages, AM is still very useful for long distance communication because its signal can travel by ground wave as well as sky wave. Skywave propagation allows AM signal to bounce off an ionosphere and reach large distance across countries. Now we have frequency modulation. So in frequency modulation, instead of amplitude, the frequency of the carrier is varied based on the amplitude of the message signal. The amplitude stays constant, which is the key reason of frequency modulation provides excellent noise immunity. Because noise mostly affects amplitude and not frequency, frequency modulation receivers can remove unwanted variations easily. This results in very clear, high quality audio with less distortion. Frequency modulation requires a much larger bandwidth than amplitude modulation. Commercial frequency modulation broadcasting uses about 180 to 200 kHz of bandwidth because it supports high fidelity music stereo transmission. FM operates in the VHF band, which is 88 to 108 MHz. This higher frequency supports better audio quality but limits the range because FM signals mostly travel in line of sight paths. FM is ideal for city-based broadcasting and applications needing clarity such as music stations and emergency services. Now applications of AM and FM. So different applications use AM and FM depending on distance, audio quality and cost. First of all, AM is used in aviation communication because it works very long range. Then we have shortwave radio, emergency alerts and long distance communicating using many of the channels. Then we have FM. It is highly used in high quality music broadcasting, police, fire and emergency radio systems, TV audio transmission. And AM focus on coverage while FM focuses on clarity. And by this we can say that if we want clarity we can use FM, but if we want coverage and long distance we can use AM for it. Then advantages of AM and FM. So first of all, AM is the biggest advantage for simplicity and long range coverage. As we have seen back that AM travels more than FM. AM transmitters and receivers are affordable, simple to build and can cover extremely large areas using skywave propagation. Whereas FM on the other hand offers much better sound quality because it is resistant to noise. Its constant amplitude signal reduces issues like fading and interference. FM also supports stereo sound features which displays text such as radio station names. So AM is better for communication over long distance while FM is better for delivering high quality noise and audios. Now what is disadvantages? As we all know, some of the disadvantages also there. So AM has several limitations including low audio quality and high noise sensitivity. It can be easily affected by electrical devices, thunderstorms, or atmospheric changes. Because its bandwidth is low, AM cannot deliver very rich sound, especially for music, whereas FM, while offering great audio, has its own disadvantages. It requires a much larger bandwidth, which makes spectrum allocation more challenging. FM signals do not travel long distance and are mostly limited to line of sight communication. FM receivers and transmitters are also more complex and expensive compared to an AM systems. Then we have conclusion. So to conclude, AM and FM are both essential modulation techniques but used for different needs. AM is simple and inexpensive and perfect for long distance national coverage, whereas FM provides superior sound quality and it is widely used for better and clarity of music and audios. And engineers choose between AM and FM based factors like noise environment, required bandwidth, desired audio quality, and communication distance. Even today, in digital technologies, AM and FM remain fundamental in many communication fields and continue to be reliable methods for analog broadcasting. As we all need clarity of music, so FM is widely used, and we have to communicate through long range. So AM is used. So after seeing all this, we can say that AM and FM are widely used still in day-to-day life. Thank you.